Everybody, let's spend a little bit of time getting into actually naming some ionic compounds, particularly binary ionic compounds in this video. Whenever we're naming ionic compounds, we want to first identify if the compound is really ionic. There are two different naming systems. Actually, there's 3 or 4 or 5 different naming systems. In this, there are two that are popular. So there's one system where we name covalent compounds, okay, or molecular compounds, okay, and that's the prefix, element prefix rudide. But then we have to see if it's, and then we have a system for naming ionic compounds. We are only talking about ionic compounds here. We are not talking about covalent. So keep in mind that covalent compounds are usually between nonmetals. Okay? So this is nonmetal, nonmetal. As soon as you see some sort of metal, then we know it's ionic, and now we can do this. Okay? So when we name ionic compounds, we're going to name it, we're going to go cation, and then we're going to name the anion. So the positively charged thing, and then the negatively charged thing. And in this case, we're not going to use prefixes when we're doing the two elements, okay, when we're doing the two ions. We're only just going to say the name of the cation, we're going to say the name of the anion. It's going to be super straightforward, okay? There's no tetra or hexa or whatever, okay? And then we're also not going to use the word ion when we name them, okay? So sometimes people, because they're like, oh, all I have to do is name the cation and name the anion, some people will be like, sodium ion, chloride ion. No, it's just sodium chloride. Okay, so don't use that, okay? So when we compare these to covalent compounds, like I said above, covalent compounds are nonmetals exclusively. Okay, ionic compounds are metals. So when we compare these, I guess, compare and contrast, this is metal, non-metal, okay? That's one difference. Another difference is that covalent compounds are actual linkages, actual bonds, whereas ionic compounds, they are just an attraction. And so back when we talked about attractive forces, okay, you'll have a cation like sodium. That's positive. This guy is negative. They are just attracted to each other. Whereas a covalent compound is, let's say, hydrogen and oxygen, and then hydrogen. It's an actual overlapping of the electrons and their sharing. So this is a bond that's way harder to break, as opposed to here that is just an attraction between two oppositely charged things. So let's name some of these guys. Okay, so all we have to do is name the element. I'm sorry, not the element. We have to name the two ions. So this is the sodium ion, this is the chloride ion. So this guy is going to be sodium chloride. Notice I'm not capitalizing any of these things throughout any of these examples. Elements and compounds don't get capitalized. They're not proper names. Okay, they're just names. Okay, they're just other words. So we don't capitalize these things. Okay, so this is, again, calcium and nitrogen. So this is the calcium ion and the nitride ion. So it's calcium nitride. Notice we are not putting any prefixes here, because the reason why is because calcium always has a 2+ charge. Nitrogen always has a 3- charge. So because the charges are set, we know that in order to get this to even out, you have to have 3 calciums, okay, and then you also have to have 2 nitrogens. What is the least common multiple of 2 and 3? That least common multiple is 6. I'll show you this in a later video too, but I just wanted to go over this so that way you know why there are no prefixes here. So if we're trying to get to 6, we're trying to get the charges to cancel out. So in order to do that, they have to be equal. We need 6 positive charges. So that means we need 3 calciums. So I'm going to put another calcium and another calcium here. So that means there's 6 pluses. And now we need 6 negative charges. So that's 6 negative. So if we added up the charges here, this is going to be 6 plus, this is going to be 6 minus. They cancel out to give us a neutral compound. And so the only ratio that these guys can be in is 3 to 2. Calcium nitride can only be found as a compound that has a ratio of 3 calciums to 2 nitrogens. That's what makes ionic compounds different when we name them. Okay, so let's keep moving on. Okay, so this is aluminum oxide. Now, here we have a transition metal. So remember, the rule with transition metals is that we need to put the charge in parentheses of the transition metal when we name it. So this isn't just iron oxide, because if that were true, these two things would be the same compound. This would be named iron oxide and this would be named iron oxide. But that's not the case. These two things are two totally different compounds with different physical and chemical properties. So there should be different names. Just like in real life, when things have different properties, they should have different names, okay? So, let's look at this. This is how I do this. I'm going to say iron oxide, because I know that it's going to be iron and oxide. The only problem is going to be trying to figure out the charge on the transition metal. Well, in order to do that, we know what the charge on oxygen is. The charge on oxygen is 2 minus. So just like back up here when we talked about calcium, we want to make sure that the charges balance each other out. So here we have 3 oxygen ions, and each one has a 2 minus charge. So if those 3 oxygen ions have 2 minus charge, what is the overall charge? The overall charge that has to cancel out is 6. 3 times 2 is 6. So this side is 6 minus. So now what does the charge on iron have to be in this case? It has to be 3 plus, because 2 times 3 is 6. So the number that goes in parentheses is the charge. So that's going to be iron 3 oxide. Okay, so again, we'll do that here. Iron oxide. Parentheses. Now, in order to do this, again, we're going to do minus. And now there's only one of them. So if there's only one of them, 1 and a 2 minus, that means that we want the charges to add up to 2. Well, there's only one iron, and so that means this charge has to be 2 plus, so the number that goes in the parentheses is a 2. So this is iron 2 oxide. This guy is iron 3 oxide. Okay, so now this here, okay, we know that it's a transition metal, so we're going to go cobalt. I'm going to put this here, transition metal, and then it's cobalt chloride, okay, because that's the chloride ion. What's the charge on the cobalt? Well, again, same thing. We can do a 1 minus, and there's 2 of them, so that's 2. There's only 1 here, so this is going to be 2 plus, because there's only 1. 1 times 2 is 2. Okay, so the number that goes in the parentheses is a 2, Roman numeral 2. Now, how about this one? Kind of my favorite one up to this point. It's mu. And so let's look at it again. So this is, if we're going to do this, this is going to be molybdenum. Okay, and then we're going to parentheses oxide. And I'm not capitalizing these on purpose. Okay, so we know molybdenum oxide. So what's the charge on oxygen? Oxygen is always a 2- charge. And there's one of them. So that means that we want both the anions and the cations to add up to be 2 somehow. And so how many molybdenums are there? Well, there's 1. So that means that this has to be a 2+. So that's molybdenum 2 oxide. Okay, so this guy, great. This is vanadium. And if you don't know your periodic table elements, not the periodic table of elements, but if you don't know the elements, this is, over the next few times, we're going to get to know them. So this is vanadium something bromide. Okay, so what's the something? Well, again, we go through the same thing that we have been. Vanadium something bromide. So bromine is always a 1- charge. There's 3 total of them. So 3 at a -1 charge each is a total of 3 charges. Now there's only one bromine, or only one vanadium, so each one has to have a the vanadium has to have a 3+ charge, so this is going to be vanadium 3 bromide. Okay, almost done. So now, how about this guy? This guy is a little bit easier. Magnesium is not a transition metal. It's a main group metal. So we're just going to name this magnesium iodide. Iodide. Okay. And then last but not least is this guy. Okay. Silver chloride. Whoop. Sorry, I didn't mean to do that. Okay, but silver chloride, notice I didn't put a space here because silver is one of those transition metals. It's an exception. I always call them exceptions that prove the rule. Silver is an exception where we always know its charge is going to be 1+. So that is, so we don't put the number in parentheses here. And actually, I'm kind of jerky enough that if you do put numbers in parentheses, I would mark it wrong. The whole point of having a system of naming is that it's consistent worldwide. So if I know what Cobalt chloride is in America, I'll know what it is in China, and I'll know what it is in Russia, and I'll know what it is in South Africa, and I'll know what it is in Egypt, and I'll know what it is in Spain. Okay? That is the whole reason for having systems of naming. So if I write Cobalt chloride, that name is not correct no matter where you are. And so if I did silver 1 chloride, that is not the correct name no matter where you are. That name is incorrect. Okay? So you're going to have to make sure you know how to name these guys, write the names correctly. Okay, so have a great day, and I hope you enjoy naming binary ionic compounds.